Thank you. I've been at Sauce Labs for about a year, and I want to give you a little bit of a vantage into exactly what we've gone through over the last year and how we've gotten to what I really think is a very good position to call ourselves DevOps at this point. First of all, obviously we wanted to talk about what DevOps is before I can tell you how we got to DevOps, right? So to me, this is a very good idea of where we want to go, where we've been, where we want to go from an evolutionary perspective. You're starting with the Waterfall Days. We were barely walking around on all fours, all the way to the Terminator days, in what I call continuous operations. It goes beyond continuous development to me. Continuous operations to me is almost a self-healing system, but that's another topic. We'll talk about that some other day. So let's go back to the beginning of time, right? Before we can talk about DevOps, we've got to talk about how the heck did we get here. Well, in the beginning, of course, there were computers, right? There were all kinds of business problems that we had, and we wanted to figure out how we can use these wonderful machines to help us out. These great machines came out, and we were able to compute a lot of different types of calculations, and to help us out from certainly from an accounting perspective, and a lot of those different types of things. We started using them first because they were very expensive in the big major programs like the space program and in military and so forth. But pretty soon we started using them in business. What we realized was that these computers and programmers were not cheap. They were very expensive. So we started creating methodologies so that we could more effectively use these resources that we had. So Waterfall was born. We created the methodologies to prevent buggy systems. I mean, that really was the thinking in those days, is there's got to be a way that we can systematically stop bugs from happening. And so Waterfall, like I said, was born, and everybody thought that this was the panacea. This was going to be where we wanted to go. Well, as it turned out, that Waterfall was a gated approach that really didn't deliver to expectations. First of all, the majority of the Waterfall projects failed. I mean, a majority of Waterfall projects failed at all to give us the results that we wanted to get. If they were delivered, the functionality was often different than what it was that we wanted to achieve. And even when that functionality was the same as the spec that we had originally intended on, by the time you got done with it, 12, 18, 24 months later, it wasn't really what you needed. So even though people were following a methodology and actually getting the results that they thought they were going to get in terms of what they spec'd out, we realized that we as humans aren't perfect. We just can't, in a binary way, specify what it is that we're going to need in order to meet the needs the demands that we've got, especially in this day and age when things change so quickly. As time went on, components got cheaper, computers got cheaper. The internet comes along, so now we have access to all kinds of information. Programming and programmers became mainstream, so we had a lot more developers that were empowered to put together systems that helped us get to where we want to be and to develop the systems that we needed. We also had these shared libraries. We still hadn't quite gotten to open source yet. We had these shared libraries that people could use and download, and so we were able to spread that information and really share it across the board. All of a sudden, the power of the computer and the power of the network starts spreading. We started putting best practices into place. So again, the idea here was, let's try to get to the place where we can specify what it is that we want, develop what it is that we specified, and have no bugs. Right, so the whole time we've been trying to get to a point where we weren't putting bugs or getting bugs out there. So we finally got to source code control management systems. We got to all kinds of other great environments that allowed us to get to a much more stable place. So TDD comes along, continuous integration, and then finally the open source movement comes along. So great, now we're harnessing the power of the environment, of the community. And we're getting better and better at all of this. But we still found that there was something lacking. Something just wasn't getting us to where we wanted to be. And the reason was that things change. Things change, and we just cannot predict where we want to be in 6 months or a year for sure. So with a lot of the barriers partially removed, we realized that we needed to get a better way of collaborating between the business and technology, all the technologists and so forth. So in the late 90s, a new methodology came along, a new mindset called Agile. This is where you guys come in, right? So Agile has been kind of the latest mindset for the past 10, 20 years. Really, it's been about 20 years, but it's really been in the mainstream for only the last 5 or 10 years or so, where people have really adopted this. And the goal here was to bring, as I said, business and technology together to get that dialogue, to favor dialogue over these gates that we used to have. In the old days, we actually had gates where you couldn't get to, you couldn't even talk about something down the road until you got past a certain gate. What we realized here was that no, we really need to talk about the overall system that we wanted in order to really be successful from this perspective. We really realized that the other thing that was going on was that we needed to make sure that we all took responsibility. We as a whole took responsibility for the system, as opposed to really making, really finger pointing at each of the different parts of the organization that were making the decisions. And we wanted to really, one of the big things about Agile was that we wanted to break these big complex systems into small deliverables so that we could understand and change as we went along the requirements, and be able to really deliver what the business needed, not what we thought we needed from the very beginning. But we're still a long way away from developing quality systems at pace. And we were moving pretty fast. We were developing stuff very fast, but those damn bugs were still there. Why were the bugs still there? And why were we delivering stuff that really wasn't getting us to exactly where we wanted to get? Well, the problem was that we weren't thinking about the big picture. We weren't thinking about the big story. We were thinking about those local maxima, right? We were really optimizing on those the small deliverables, but we weren't thinking about the whole picture. So this is where DevOps comes in. So in DevOps, you really want to think about the big picture, the entire system, not just the parts. The disillusionment, and believe me, there's disillusionment with Agile, especially in big companies. There's a lot of disillusionment with Agile. And that comes from the fact that Agile promises all these great things. It promises that you're going to get what you need, and it promises that it's going to go really fast. But the problem is, again, Agile tends to work for small systems, but not for larger systems. And so what we needed to do is figure out how we can take this Agile mentality and really apply it to larger systems. Understand how we can take all of these principles and deliver on the large business impact, the business value, rather than just the little parts of it. And the key to that is collaboration, all right? So when you look at the theory of constraints, you realize that a system overall is going to be only as fast as the slowest link in the chain, right? It's only going to be as good as the weakest link in the chain. So you have to understand how to look at that big picture, and the only way to do that is to collaborate, to really make sure that everybody from all parts of the business are talking to each other and really understanding what the large goal is going to be. So what we needed to do is we need to look at all of the bottlenecks that are there. So what are these bottlenecks? What are the bottlenecks of this big system? Well, there's almost too many to count. Very first thing as developers that we run into when we're trying to build a system is that the provisioning of infrastructure takes too slow, right? You want a server, ops says, sure, no problem. We'll have it in 6 weeks. You're going, 6 weeks? Oh my God. The world is going to change in 6 weeks. Developers and operations don't work in silos. So often the developers do a bunch of work and they just throw it over the wall, and ops says, great, what do I do with this, right? And even if they do understand how to deploy something, they don't know how to monitor it. They don't know when something is going wrong. The developers are saying, well, you should. It's your systems. I mean, how do you not know how to monitor this? How do you not know how to do this? There's a lack of test automation in many systems, and that, of course, is going to slow you down. That's going to stop you, in fact, from doing continuous integration and continuous deployment. Or there's no test automation or no testing at all. There's manual software and database deployments. There are different environment. There's a different environment landscape. In other words, dev looks different than staging. That then looks different than production. So what one of the famous sayings is, it works on my computer, right? Well, it doesn't work on production for some reason. So you have to make sure that you've got over that bottleneck. Change requests take too much time. For when you make a request of ops, for example, it takes a long time, so that slows you way down. Server software is installed by a different group than the people who are actually writing the systems for. There's a lack of continuous integration tooling. There's a lack of support for the code. I mean, just on and on and on. There's all these different things that stop you. Well, how the heck are we going to get past all of these different bottlenecks? Well, that gets us to DevOps. All right, so DevOps to the rescue. Bottlenecks have one thing in common, as I said earlier, and that's a lack of collaboration. So DevOps really, to me, is a mindset, and that mindset is that we need to increase collaboration by getting people to work together as one team. The team is composed of all of the collaborators toward the delivery of that business value. We have to stop thinking about this app or that app. We have to start thinking about business value. What's the business value that we need to deliver? And so by collaborating between it ensures that the requirements are written following a BDD approach, right, a behavior-driven development approach. That code is developed by taking operations needs into mind as well as just the software needs. Making sure that the infrastructure is provisioned and configured automatically. The last thing you want is you got the code done. How do we get the provisioning, the infrastructure provision so that we can get this out to production? And we need to make sure that the code is continuously built, tested, and deployed. You have to have that cycle because otherwise it's going to slow you down and it stops you dead in your tracks. And you have to make sure that the solutions, and this is one of the things that, because I'm a developer from way back, one of the last things you want to think about is what are the non-functional requirements for this system? Either from an operations perspective, right? How do I monitor the system? How do I make sure that we are able to know how to fix this system? How do we make sure that we can have an elastic system so that if there's more capacity is necessary, how can we make that automatic and so forth? Those are the types of things that a lot of developers don't think about. And certainly that's one of the things that product managers don't think about, right? Product owners often don't think of those things. They want the feature out there. They don't really think about, well, what happens when we go from 1 million users to 10 million users? And so that's why you have to have all of those different areas collaborating. And that, to me, is what DevOps is all about. You have all of those people in a room working, and in fact, on the same project team, working together. It's kind of a pain in the ass if you're any one of these people, because that means that your needs are not the only needs that are going to be met. Right? If you're a developer, you really, or certainly a product owner, you want those features out there. You want those users to be really happy with those things. You don't want to spend a month making sure that the monitoring is there. You don't want to spend weeks making sure that the automated tests are all written. You don't want to have to spend weeks and weeks on all of these non-functional types of requirements. But in the end, it actually saves you time, because in the end, all of this stuff means that that you're not going to have to go back and fix all of that technical debt. So, to me, the cornerstones of DevOps, of successful DevOps strategy, are these 5 things. Technology. We need to make sure that we use technology as an enabler. That's a no-brainer, right? Automation. We need to make sure that every phase of the software development lifecycle is automated. Every single phase. Repeatability. Again, I talked about the fact that development needs to look like QA, needs to look like stage, needs to look like production. We need to make sure that all of that is repeatable. That we can, that when we deploy to any one of these places, that it's the same thing. Consistency. Automation repeatability makes sure that we are consistent across the board. And then finally, collaboration. I've gone on and on about collaboration. It is an absolute must that we collaborate to make sure that we're looking at the big picture and that we're looking at all of these things, because otherwise something is going to drop between the cracks. So let me tell you about how now the whole topic was our journey at Sauce to DevOps. Let me tell you about how we use these 5 different areas. So in technology, when I first got to Sauce, the company was about 6.5, 7 years old. And so think about a 6-year-old startup. What it means is that these developers have been getting features out at a furious pace. We are running somewhere around 2 million tests a day for our customers, which means that we're a pretty large scale. I mean, this is a pretty large scale system that we run. What was happening was that we were so bogged down with operational issues that as things were going down, they were kind of fragile at this point. We were so bogged down with operational issues that we weren't able to move forward anymore. So the very first thing that I did is I said, look, we need to take whatever it takes, whatever time it takes to get to stability, because otherwise we're not going to be able to innovate, we're not going to be able to create new features for our customers. So it took us like a full 2 quarters, and I got the support of everybody from the CEO on down to take whatever time it took us to get to stability. Our target has been 4 nines. It's kind of funny looking back at a lot of our contracts. Our SLAs for some of our customers say 99.5, I think, on some. I'm going, oh my God, how's that possible? Somebody actually signed this? I wouldn't sign it. But people, I guess, were desperate for this stuff. So we're at about 99.99. We're about 4 nines now. It took us a little while, but we got there. But like I said, it took a concerted effort by the entire group. And it was a collaborative effort, because I had to convince product management that this was more important than building new features. Data center expansion. Again, we were at about 1 million tests a day then. We've got to about 2 million tests a day. We needed to make sure that we had the capacity to do this. And by the way, we had 1 data center. What happened if we had an earthquake? Holy crap. I mean, there's no disaster recovery that's going to get us out of there. So we opened up a second data center. We had to make sure that we were able to build out the capacity and that there was a disaster recovery plan. Everybody's probably faced this third one here. Monolithic architecture needed to move to microservices. It is just, what happens with a startup is you start building. We have the best intentions in mind. You want to make sure that you're building it with a great architecture, but things are moving way too fast. So all of a sudden, you've got this big ball of spaghetti code all over the place. And in order for us to maintain that, again, it was taking way too much time. When I got there, people were saying, I said, what is the biggest problem that you have to people? They said, well, just the build, having the build and having it go out to production, it's take us like a whole day. I said, what? And it was because in order to put anything out into production, you had to build everything, and you had to deploy everything, the entire system, not just little pieces of it. Clearly, you need to slow down and figure that out. We've broken things into microservices so that you can deploy one thing at a time, which also helps, obviously, with scalability. Third-party tools. This is one of the things that startups are really bad about. Startups love to build everything. They build all of these things, and we were no exception. One of the examples is that we moved to Sumo Logic from this Elk Stack application that we had built to do log monitoring and so forth. It was really cool what we had built, but I had 2 full-time developers just supporting this thing. And it was slow, and it wasn't getting us where we wanted. And we had to go make sure that we had the infrastructure for all that storage. And we had to, just all of these different problems. And it was solved by spending a little money and going out and getting Sumo Logic. And there were many, many other examples of this. Go out and get those third-party tools. There are a reason that these companies are out there in business. This is not your business. This is their business. This will allow you to get to that point of what your core competency is. Infrastructure management. We had, again, imagine, we run a couple million tests a day. We've got hundreds and thousands of servers. When I got there, I said, well, how do you keep track of all these? Oh, we've got a spreadsheet. A spreadsheet? Okay, so we got Device 42 and a lot of other different things to monitor all of this stuff. One of the things that we also run today is what we call a real device cloud. So not only can you test on emulators, simulators, and on desktops, but you can also do automated testing on real devices. So now we're talking about thousands of phones. How are you going to keep track of all those things on a spreadsheet? Make sure that you make the investment to understand how to manage your internal infrastructure with third-party tools. An artifact repository. Again, we have something on the order of 700 or 800 different OS browser images that we support, combinations. And each of those is an image that goes out onto a VM. Well, again, I asked, how do we do this? Oh, we put it in a file system somewhere. It's like, let's find, let's use something that is actually meant for this kind of thing. REST API management. When back in December of last year, into January of this year, we had a particular problem where we went down all the time. And I was trying to figure out what is it that's the problem here. It turned out that we had just released a new version of our UI, and it had this really, really cool graph. And what it did is it showed you all of the jobs that you were running, all of the tests that you were running, and it did it in some really great visual ways. Now, the problem with that is, of course, the UI people had not really tested this at a high capacity. So some of our customers who are running millions of jobs would come in and they'd start looking at it, and they'd start playing around with it, which, of course, would take the database down because it was just too many requests. At the same time, we had a different customer who had a bug in their code, and they were calling our API. So these graphs were fueled by an API to the database. That same API was run by some of our customers for their own graphs. And so they had a bug where they were hitting us at about 100 times what they normally hit us at, which of course also took the database down. And I said, well, let's look at this. Don't we use some third-party package to do some of the normal rate limiting that we do with APIs? No, it's something that we had built internally. So again, these are those third-party, these are those non-functional things that you don't often think about, that the ops team could have told you from right away, or that at least the database guys could have said, look, we're going to have some issues here, but they weren't talking to the UI guys, and the UI guys weren't talking to them. Collaboration is the big key there. Automation. Our desktop platform support team is the team that builds all of those images for the desktop platform. So the OS browser combinations for PC, for Mac, all of etc. They were in the old days. It was really easy to create the images. That's not too tough. But as time went by, you understand how often the browsers update their images, right? They do it every couple of weeks now. And so to do this every couple of weeks, either you got to have a really big team or you got to automate this. So that was another thing that we had to do is understand that whole process. Same thing with our emulators and simulators. We had to make sure that all of that was automated because it just wasn't taking place anymore. And again, this was never prioritized because the product managers just wanted those images out. They never really were talking. They didn't have the technologists at the table to say, look, we really need to automate this because it's going to catch up with us. Mac provisioning. The poor guys in ops were provisioning these Macs, and we were bringing hundreds of Macs to our data center, and they were provisioning these things manually. So again, they didn't have a seat at the table. The collaboration wasn't there, so that wasn't prioritized. It was never prioritized. It was just bring these things on. Code deployment. We're a testing company, and we weren't really doing true CI. Code deployment again was kind of pushed out manually. So this was again another thing that the teams were being really pushed to get features out there and not really to work on the infrastructure. So it's a real, not only do people have to be there, but they have to be insistent that we have to put these systems into place because longer term, it's really going to kill us if we don't. Metrics, again, both from an operational perspective and really even from a development perspective, we didn't have a lot of the metrics that measured how quickly we were doing. So therefore, we couldn't understand whether we were actually getting better or not. There's no way you can know if you're getting better or not if you don't measure things. And then test all the things. I put this in here because it's funny. We at Sauce Lab, this is one of our logos, our sayings is test all the things. We weren't testing all the things, which is kind of ironic And again, it was because we didn't have everybody at the table insisting that we do all of these things. Repeatability. I was talking about the dev environment doesn't look like the QA environment, doesn't look like the staging environment, and it certainly doesn't look like the production environment. Well, here, even the production environment, all the machines didn't look the same, right? Again, think of it, a startup, you buy whatever you can. I was talking to people and saying, where do you provision this stuff? They go, oh, we go to eBay and we buy some of this stuff. I'm like, you go where? So snowflake removal was one of the things we needed to do. We need to make sure that all of the systems, at least within production, look the same. Because otherwise, I mean, there were some systems that didn't have the same amount of RAM as other systems. How are you going to know, how are you going to be able to manage that? Process standardization, again, this is one of the things that really is a heartache for people, because it feels like bureaucracy to them. It really feels like, wait a minute, we're going to put some policies into place, especially coming from a startup environment. As you grow up, it becomes very difficult or it becomes a little bit difficult to put this process into place. But you have to do it, because otherwise you're not going to be able to consistently repeat things as you go along. Tooling standardization, I talked about. Kubernetes, we didn't, again, look back where we started. This was back 8 years ago. Docker hadn't really taken a hold as much as it has now. We really needed to make sure that we came to the 21st century and really built some of this stuff in containers. Load testing, performance testing, again, you can't improve what you don't measure. And this was one of the things that we just kind of took for granted. It was almost like our customers will tell us when things aren't going well. That's not a good mantra. It just isn't. So we implemented these as well. Consistency, we needed to make sure that everybody understood what their role was. Everybody understood what the responsibilities were. So we put together, started with an engineering manifesto. Here's how we do things. So that it was very consistent how all of these different teams. When I got there to SOS, we were about 20 people or so. Very quickly, we got to about 50 people. So now we're talking about 10, 12, 15 Scrum teams. And each one wanted to do their own thing. And that's one of the things that Agile kind of teaches. Everybody gets to choose what they do. Well, that's great, but if everybody is using a different tool and so forth and so on, it's going to be very difficult to scale from that perspective. And so I didn't want to be onerous, I didn't want to be dictatorial, but I wanted to make sure that we all were doing the things in the same way. That way, if people wanted to move around from one Scrum team to another, or if people wanted to collaborate with each other, we were all doing things in relatively the same way. And this is a very, very important part, having a manifesto, because this is an agreement with everybody about how we're going to do everything, from things like, we're in an open environment. We give everybody a pair of headphones. And so we went down to the detail of how do you interrupt somebody? How about if you want to talk to somebody, how do you do that? Because otherwise what happens is people come up and whenever you want to talk to somebody, you just tap on their shoulder. That's very, very disruptive. So that's one, we went down to that detail and said, okay, look, the very first thing is you go to Slack and they'll get back to you, right? And that worked out very well. The only a better way would be to build offices for everybody, but that wasn't going to happen. Transparency, this is actually one of the values that was already there when I got there, so that was relatively easy, but we wanted to make sure that everybody knew that. We made sure that was part of the manifesto. Continuous improvement, this is one of my mantras, for sure. We need to make sure that we're getting better every day, every week, every month, every quarter, every year. And little by little, it makes a tremendous difference. And that's one of the hallmarks, I think, of my organizations that I've built is I want to make sure that we are continuously improving. And as I said earlier, the only way you can do that is by making sure that you measure everything that you want to improve at. I talked about environment standardization and the KPIs, of course, in order to be able to measure all this. And then finally, collaboration. I brought on board, these guys were doing, when I came in, they said, oh yeah, no, we're doing Agile, kinda, sorta. So I brought in something I called pragmatic Scrum. And I emphasize that word pragmatic because anything that's dogmatic, I don't care what process you bring in, it's doomed to fail. Because what it means is that people are going to follow the letter of the law. I remember walking in on an argument between a couple of engineers and said, what's going on? And one engineer said, look, it says right here, this is the way they were supposed to do it. And I said, well, does that make sense? Well, no, but it says so right here. I said, well, wait a minute, come on. It's got to make sense. You've got to be pragmatic about these things. At a previous company, I had the similar experience, and what I did is I actually made these T-shirts that said, Scrum, it depends on common sense. I mean, you really have to make sure that you're pragmatic about these things, otherwise it's really going to slow you down. We have dedicated feature teams, so every team has everything that they need to get things done. They have an operations person, they have developers. There's no QA. The developers write their own tests. They have a product owner, and then depending on the team, you might have a database person. You might have, it really depends on what it is that you need, but you have to be self-sufficient, 100% self-sufficient. I instituted a mentality that I call the owner-operator model. In our space, it's particularly important because we're very much infrastructure heavy. Again, imagine 2 million tests a day. You have to know what's out in the data center. Not necessarily down to the machine, but certainly you have to know how to operate it and at least how to monitor things and what to do when something goes wrong. And I made sure that everybody was on pager duty, all the developers. It's not just the operations people, because what happens at that point is you bet they're going to make sure that quality is the number one thing that they think about when they're developing things. And it worked. It actually worked. Like I said, we're up to 4 nines at this point. People don't like getting woken up in the middle of the night. It turns out it's kind of funny that way. We also made sure that there was a real strict definition of done. Again, you need to make sure that you set the specific goal of what you want in order to be able to hit that target. The definition of done didn't mean that the code is written, because I've actually seen that before where people have these swim lanes that'll say, okay, the code is written, so the QA person's got to take over. All right, now it's tested, so the ops person's got to take over. No, it's the whole team. Again, that DevOps mentality, the whole team has to be part of this. And what that leads to, and it's one of the things I really want to have happen, what that leads to is pairing. I never mandated pairing. I never really want to do that, because to me it's kind of if you mandate something like that, people will do it dogmatically, and they'll sit there sometimes when they don't really have to, and they'll sit there and pair, right? But what it did is it led to pairing. It led to 3 people getting in a room together. It led to a collaboration in a very natural way. And I also said you have to make sure you take monitoring into account, because again, in the old days, what happens is ops comes and says, please have some monitoring here, and it never happens, right? But if it's in the definition of done, people want to get story points done. Gamification is really, really interesting from this perspective, right? Getting those story points done, by God, that is a big motivator. And if you can't get those story points done until the monitoring is done, until the capacity planning is done, they'll do it. It's very interesting. It's quite a motivator. And then finally, one of the last things that people think about until it's too late is security. We have gone from servicing a lot of small companies to really now moving into the enterprise. And in the enterprise, when you deal with an American Express, a Capital One, a Bank of America, security is the very first thing that they come and look at. And so we need to make sure that we have systems in place. Again, if you automate this stuff, it's not a big deal. I put it in the definition of done because then people had to actually think about it. And we are actually, like I said, we have these customers and talk about strict security requirements. We have passed those security requirements, and we're able to do all of this stuff. Now, all of this, what it's led to is a really great collaborative environment where people are taking all of this stuff into account. We've got our reliability up. We are able to move forward with building new things now. It took us, I've been here, like I said, for about a year. It took us a year really to get to the point of really starting back up and building the new features that we wanted to build a year ago. But had we not done this, had we not gone to this new mindset, we would still be struggling with all of these different issues. And then collaboration tools, there's just a plethora of that, but use technology in order to allow you to do that collaboration. It will really, really help. And that's it.